Estimating the time required for rewiring a house with knob and spool wiring involves several factors. Firstly, consider the size of the house, measured in square footage, as this directly impacts the amount of wiring needed and the time spent running it. Secondly, the number of rooms and fixtures influences the complexity of the job, with more fixtures requiring more wiring and connections. Thirdly, the presence of attic insulation, particularly blown insulation, can significantly increase the time, as it may need to be temporarily removed and then replaced to access wiring. Lath and plaster wall construction also affects the time because breaking through this material for new wiring can be labor-intensive compared to drywall. Accessibility of wiring, whether it's behind walls or in ceilings, plays a role, as difficult to reach areas can slow down the process. Local code requirements, specifically compliance with 5 codes, can add time due to inspections and approvals needed throughout the project. When estimating the time, different house sizes can be grouped. For a small house under 1,500 square feet, the rewiring might take approximately 2 to 4 weeks. For a medium-sized house between 1,500 and 2,500 square feet, plan for 4 to 6 weeks. For larger houses exceeding 2,500 square feet, the project could take 6 to 8 weeks or even longer, depending on the specific conditions. When blown insulation is present in the attic, it needs to be removed and replaced, which adds to the overall time. Lath and plaster requires more effort to work with compared to modern drywall, increasing the time spent on wiring installation. Wiring behind walls and in ceilings often necessitates more intricate work, extending the project duration. Ensuring the new wiring complies with the relevant electrical codes requires time for inspections and necessary adjustments. For more accurate estimation, breaking the job down into smaller tasks can be helpful. Demolition of the old wiring requires time. Installing the new wiring takes time. The installation of new fixtures takes time. Inspections and approvals take time. Estimate the time required for each of these tasks individually, drawing on previous experience and industry standards. Account for potential delays that might arise due to unforeseen circumstances or material shortages. Include a buffer in the overall estimate to accommodate unexpected issues. It's advisable to obtain multiple bids from licensed electricians to compare their estimated timeframes and costs. This can help determine a reasonable and accurate timeline for the rewiring project. Before starting any electrical work, it's crucial to prioritize safety and ensure all work complies with local electrical codes. It is important to understand common electrical terms and concepts such as voltage, amperage, and resistance. Voltage is the electrical potential difference between 2 points in a circuit measured in volts. Amperage is the measure of electrical current, or the rate of flow of electric charge measured in amps. Resistance is the opposition to the flow of electric current measured in ohms. These are fundamental quantities in electrical circuits. The National Electrical Code, or NEC, is a widely adopted standard for safe electrical installation. It contains guidelines and regulations to ensure electrical systems are installed in a safe manner. Referencing NEC tables, such as Table 310.15b16, provides guidance on the allowable ampacities of conductors. For example, this table specifies the maximum current a conductor can carry safely based on its insulation type and ambient temperature. Suppose you are working on a residential circuit that requires a 20 amp breaker. To determine the appropriate wire gauge, you would refer to NEC Table 310.15b16. For copper conductors with a temperature rating of 75 degrees Celsius, you would typically need a number 12 American wire gauge, or AUG wire. However, it is essential to consider any dirting factors that may apply due to ambient temperature or the number of current-carrying conductors in a raceway. Proper grounding and bonding are crucial for electrical safety. Grounding provides a path for fault current to return to the source, tripping the circuit breaker and preventing electrical shock. Bonding ensures that all metallic parts of an electrical system are at the same potential, reducing the risk of shock. Ground fault circuit interrupters, or GFCIs, are essential safety devices that protect against electrical shock. They monitor the current flowing in a circuit and quickly trip if they detect a difference between the outgoing and return current, indicating a ground fault. GFCIs are required in areas where electrical outlets are near water sources, such as bathrooms and kitchens. Arc fault circuit interrupters, or FCIs, are designed to protect against fires caused by arc faults. Arc faults occur when there is an unintentional electrical discharge between two conductors, which can generate heat and ignite nearby materials. FCIs are typically required in bedroom circuits and other areas prone to arc faults. The electrical panels should be properly labeled to clearly indicate the circuits they control. Each circuit breaker should be labeled with a description of the devices or areas it serves. This makes it easier to identify and shut off the correct circuit during maintenance or emergencies. When working on electrical circuits, always de-energize the circuit breaker before starting any work. Use a non-contact voltage tester to verify that the circuit is de-energized. This helps prevent accidental electrical shock. Use appropriate personal protective equipment, or PPE, such as insulated gloves and safety glasses, when working on electrical systems. This PPE helps protect against electrical shock and other hazards. Overcurrent protection devices, such as circuit breakers and fuses, are designed to protect electrical circuits from overloads and short circuits. They trip or blow when the current exceeds the rated capacity of the circuit, preventing damage to the wiring and equipment. When installing electrical boxes, ensure they are properly sized to accommodate the wiring and devices. The NEC specifies the minimum box fill requirements based on the number and size of conductors, devices, and equipment ground wires in the box. Use appropriate wiring methods such as non-metallic sheathed cable or NM cable for residential wiring. NM cable is commonly used for branch circuits and has a protective outer jacket. Ensure that the cable is properly supported and secured to prevent damage. When making wire connections, use appropriate connectors such as wire nuts or crimp connectors. These connectors provide a secure and reliable electrical connection. Always twist the wires together before applying the connector. When running wiring through walls or ceilings, use appropriate drill bits and techniques to avoid damaging the building structure. Be careful not to drill into plumbing or other utilities. When installing electrical fixtures, follow the manufacturer's instructions and ensure the fixture is properly grounded. Use appropriate mounting hardware to secure the fixture to the electrical box. When troubleshooting electrical problems, start by checking the circuit breaker or fuse. If the breaker is tripped or the fuse is blown, reset the breaker or replace the fuse. If the problem persists, further troubleshooting may be required. Use a multimeter to measure voltage, current, and resistance in electrical circuits. A multimeter is a valuable tool for diagnosing electrical problems. Follow safe electrical practices and always consult with a qualified electrician if you are not comfortable working on electrical systems. Electrical work can be dangerous, and it is important to take precautions to prevent electrical shock and other hazards. Remember that electrical codes and regulations may vary depending on your location. Consult with local authorities to ensure that you are following the correct codes and regulations. When planning an electrical project, create a detailed plan that includes the wiring layout, device locations, and circuit breaker schedule. This plan will help you stay organized and ensure that the project is completed correctly. Consider energy-efficient lighting options, such as LED lighting. LED lights use less energy than traditional incandescent or fluorescent lights, saving you money on your electricity bill. When installing electrical outlets, use tamper-resistant outlets, or TR outlets, especially in areas where children are present. TR outlets have internal shutters that prevent children from inserting objects into the slots. Use surge protectors to protect sensitive electronic equipment from power surges. Surge protectors can help prevent damage to computers, televisions, and other electronic devices. Consider installing a whole house surge protector, the electrical panel, to protect all of the electrical circuits in your home. Regularly inspect electrical cords and appliances for damage. Replace any cords or appliances that are damaged to prevent electrical shock or fire hazards. Avoid overloading electrical circuits by plugging too many devices into a single outlet or circuit. This can cause the circuit breaker to trip or the wiring to overheat. Use power strips with built-in circuit breakers to protect against overloading circuits. When working on electrical projects, keep a fire extinguisher nearby in case of a fire. Be prepared to evacuate the area if a fire starts. Store flammable materials away from electrical equipment and wiring. This will help prevent fires. Follow all safety precautions and guidelines when working on electrical systems. Electrical work can be dangerous, and it is important to take precautions to prevent electrical shock and other hazards. If you are unsure about any aspect of electrical work, consult with a qualified electrician. A qualified electrician can provide expert advice and ensure that the work is completed safely and correctly. Remember that electrical safety is everyone's responsibility. By following safe electrical practices, you can help prevent electrical shock, fires, and other hazards. Always prioritize safety when working with electricity.